So these are the platform rocks. So you have Bundelkhand crater. This is platform, and this will be the mobile bed, Aravalli mobile bed. Aravalli mobile bed. Aravalli mobile bed. If you come to south, here will be Central Indian Tectonic Zone. Central Indian Tectonic Zone. So that is how this platform rock occurs. So I have told you the origin of platform rocks. So you have mobile bands, that means these are the open sea, deep sea part. And this was the shallow sea or the eperic sea, bounded by the continents, very close to the continent. This remains deformed, metamorphosed, granite intrusion took place in here and here, but in the platform there is no granitic intrusion. इसमें क्लास ले रहा हूँ बात नहीं सुन रहा। So this is the platform rocks. So three important crustal types: mobile bed, crater, and the platform. They are coexisting. So this is a very good example from the Indian subcontinent. Like this, we will discuss others also. So let me just tell you what is Vindhyas in very nutshell or right. Because this is a topic the sedimentologists should cover. But I will be just giving you the overall succession and what are the sediments in it and what is the age of those sediments. Details I will not go. But what I will do, I will keep the map of Vindhyas and stratigraphic succession of Vindhyas in my site. We will upload these things in the site. You can download it and see it. I will share it with you. Because sometimes question comes, what is the Rewa limestone, Bhandara limestones, what are those things? So, overall summary I will tell you, the rest things you can take care of later. So now these Vindhyas have been subdivided into, this you might have read in your BSc days, but I am not touching upon the important things. So you have this Bundelkhand crater, the basement rocks, over there it is deposited, followed by Sembri group, then you have unconformity, Koimur group, then Rewa group. Here is normal hill scale. This is successive sedimentation. Then Rewa group. Here is disconformity. Then you have Bhandara group. BHA and DER. Bhandara group. So this is the succession of Vindhyas. Now what I wanted to tell you, you remember all those names, because sometimes in Geological Survey of India, they ask succession of Vindhyas. So you should see the details stratigraphic successions, which I will not be able to cover, but I will share with you. Now, the most important is, this is sandstone, little limestone. You read what I am telling. Then volcanics are there. Then here's shale and sandstone. Koimur. Then Rewa, sandstone and shale. Then this Bhandara is having limestone, gypsum bearing beds, Now, if you see, important part of it, Vindhyans are sandstone and shale, the clastic sediments. That means the source is from the Bundelkhand granite, Bundelkhand crater. This is craters are mostly silicic. Bundelkhand crater is silicic, so they have supplied the materials into Vindhyans. That is why it is dominated by the sandstone, shale, and pure limestone. Limestones are in Semri limestone or the Bhandari limestone. Now, you see, there are some volcanics. Basaltic volcanic rocks are there. Volcanics came from where? You see, when this Vindhyan basin formed over Bundelkhand crater. So Bundelkhand crater was something like this, you know. You can have a cross section. Like this Bundelkhand crater was like this. Over that, there are some extensions. This was extension took place and the rift valleys formed. The rift valleys. Then the rift valleys widened. It becomes a very large deposit. So here, when this rifting was taking place, this basalt, you know, from below, they came and spread during sedimentation time. These are basalts. So those volcanics are the result of this rifting of Bundelkhand crust. Because of this rifting, basalt came and deposited. Then the other sediments were deposited derived from Bundelkhand crater. Now these Vindhyans are very famous for diamond ferrous deposits. Where are those diamond ferrous deposits? In Rewa group of rocks, Rewa, there are some diamond ferrous conglomerate. Rewa you have diamond ferrous conglomerate. Then Bhandari, here also diamond ferrous conglomerate. Diamond ferrous conglomerate. So these diamond ferrous conglomerates, they are occurring toward the top part of Vindhyans, upper part of Vindhyans. Here, you see, upper part of Vindhyans. So why diamonds are occurring in the conglomerates? Because diamond is a heavy mineral. So when they were transported from the source, so they are deposited with the conglomerate, larger size particles. In sandstone they will not occur. So this unconformities are present in the Rewa and Bhandari. So the diamonds are deposited there. So what do the people do? They go on panning heavy mineral separation studies and they take out the diamond from it, from those conglomeratic beds. Now, you must have heard the name of Panna. Panna, famous for diamond deposits in the conglomerates. But from where this diamond came? This diamond came from some pipe. This diamond, I'll write down. This diamond source rock is some kimberlite pipe. Kimberlite pipe. Kimberlite pipe, after erosion, the diamonds are released from the rock and deposited in the conglomerates. So those kimberlite pipes are there in Panna, Mazgaon. Panna, just remember. So there are some diamond pipes which are occurring in Panna, and from there it has come and deposited the diamonds in the conglomerate. So this is why the Vindhyans are so famous. Now these rocks have been dated. The Vindhyan rocks, some of the dolomite dikes have been dated. Then This 1720 is the basement. 1720 million year. Summary group of rocks. 1720. And the top part they assign Bhandari group of rocks 10-20 million year. There are several types of studies. Finding the dates of the dolerite time, which is occurring at the basalt part, and they find the paleomagnetic pole. So there are some paleomagnetic poles which has been dated. By comparing these two things, they find the base of Vindhyans is 1720 million year and top part is 10-20 million year. So it's nearly 700 million year sedimentation is your Vindhyans. But there is another group of people, who says this Bhandari group of rocks, they have some fossils. Eddy current fossils. Those fossils are doubtful, but they say that yes, it is present there. These eddy current fossils, they indicate an age like 540 to 600 Cambrian age. So some people say no, the Vindhyan sedimentation has extended up to Cambrian. It is not ending at 1000 million year. 1000 million means just beginning of Neoproterozoic, but it may be continuing up to Cambrian. So this is the story of Vindhyan deposits. So I will not go details about Vindhyans anymore, but I will give you the stratigraphic succession and geological maps. This is for your reference. You may be finding it difficult to know at this point of time to remember, but during the SI exam what you will do? You refer those things in my lecture, because most of my lectures will be again in YouTube. Now, this is about Vindhyans. Now let us come to another group. You bring this map down. This is Kadapa. Where is Kadapa? Yeah. Kadapa, I will show you. You can see the Kadapa, the crescentic map, just northwest of Chennai. Now I will give a detailed map of Kadapa. Then we will discuss. Now where is Kadapa map? I will just show you. I will make it a little smaller so that let me finish what I am going to tell. Now you can see this colored map. I will draw it in the blackboard. Just you wait. So this is the crescentic shape Kadapa basin. I will draw it in the blackboard. Don't worry. Now this bright yellow part is your Nalamalai group. The oldest one is Papagini. The deep blue surrounding or dark color band is Papagini. So Papagini the oldest one. Then Chitravati group, little grey color, Chitravati group. I will draw it in the blackboard, don't do it. Then Kurnul group, light blue. Then you have in between Nalamalai and Srisailam quartzites. So this is how the Kadapa basin looks like. I will draw it in the blackboard so that you can remember, Otherwise there is no point of showing a map and talking. Now you can just draw it like this, A crescentic type of Kadapa basin. Now this part is a thrust, like this, The eastern margin is a thrust. This side is your eastern Ghats. Eastern Ghats. The other side is your Dharwar crater. Dharwar crater. Here is mostly conformable there is no thrust, but there is an unconfirmed. Here you will find the unconfirmed. Like this. Unconfirmed. Now this Kadapa basin, now you see three elements are there. One is your platform, this is platform, this is your crater, and here is your mobile bed, Eastern Ghat mobile bed. And there is a band here, which is called Nalamalai cyst band. Hey, what is that called? Yeah, I'm just unable to recollect, Okay. What is the cyst band called? I'll tell you. Nellore cyst band, sorry. My memory is now very fading, Okay. Here is a Nellore cyst band. Nellore cyst band. So this side you have Nellore cyst band, then Eastern Ghats. This is Kadapa, this is your Dharwar crater. So this Nellore cyst band, some people refer it, part of the Dharwar crater. Some says no, it is part of Eastern Ghats. There is a controversy. Nellore cyst band is a part of Eastern Ghats and Nellore cyst band is a part of crater. There is a controversy. If you want to take up some study, you should read the geology of Nellore cyst belt. Its geochronological ages, all those things sometimes reflects crater, sometimes reflects its mobile. Anyway, we will not go to that controversy now. So let us come to Kadapa. Kadapa, the most important unit, is this very bright unit. Bright unit is your Nalamalai group. Nalamalai group. This one, Nalamalai group. But the oldest one is the Papagini group. Papagini is just bordering. Here is Papagini. 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 G-H-A. Papagini group. Oldest one. The next one is here. He is placing here. So that is your Chitravati group. Chitravati group is here. Chitravati group. Then this one, Chitravati group, Nalamalai group, Srisailam quartzite. Next is Srisailam quartzite is somewhere here. Srisailam quartzite. Srisailam quartzite. Then the last one is your Kurnul group. This is your Kurnul group. Kurnul group. This one is also Kurnul group. This one. Kurnool. So this is the geological map of Kadapa, and I will give the stratigraphic succession. Just very brief stratigraphic succession. So the oldest one is Papagni. Papagni group, followed by Chitravati, group, followed by Nalamalai group, then Srisailam Karjat, then Kurnool group. Now these groups, I'll remove this part or I'll write down here. There are some dolerite dikes underlying the Kadapa. So that has produced in the age of 1800 million years. That means the Kadapa basin started its history at 1800 million years. The top part of it, the Kadapa top part, is 950 million years to 1800 million, 500 million. Some groups say 950 million is the end of Kadapa, and some people also hold that it goes to Cambrian, 500 million. Just like Vindhyans. One group says it is 1000 million years, and some people on the basis of Ediacaran fossils, they say no, it is going to Cambrian. Similarly, Kadapa, one group says 950 million years is the end of Kadapa, some people hold it 500 million years. This controversy is there for all these Purana rocks. All these Purana rocks are being passed. Okay. Now, if you take a cross section of Kadapa, I'll remove it. It is something like this, If you draw a cross section of Kadapa, it will produce some sort of, if you take a cross section like this, it will produce something like this. Here are the conglomerates. But as you go towards east, there will be very overturning folds. Then there will be thrust. Some sort of structure will yield like this. So that means this part still it is showing a conformable or nearly horizontal bed are there. But as you go towards east, because of thrusting of eastern ghats, the Kadapas are folded. Kadapa rocks are folded. Now these Kadapa rocks are folded in way overturned towards northwest or west. So this folded part, is mostly Nalamalai. Nalamalai fold bed. That's why it says Nalamalai fold bed. Because of these folds present there. But as you come towards the other side, Kurnool or Papagni, they almost describe the horizontal beds. So that is the difference in the structure. Otherwise it forms a crescent shape. The basin was in the crescent shape nature. Or because of the deformation it has assumed a crescent shape. Something like that has happened. Now this part, the western side, you must have heard the name of Latavaram. There are some Vajrakarur, Vajrakarur, Vajrakarur. In the craton, these pipes are in the craton. So those pipes, they yield diamond. Then diamond. Diamond. Vajrakarur, Latabaram. So these diamonds has been concentrated in these conglomerates. In the conglomerates. Conglomerates. You must have heard the name of Kohinoor diamond. Kohinoor diamond. It went from this place. It went from this Biswal conglomerate. Kurnul. This Kurnul group of rocks. The Biswal conglomerate of Kurnul produced this type of diamond. Kohinoor diamond. It was taken by the Britishers. Now I think it has come back to India. Very famous for diamond deposits. Same thing also for Vindhyans. Panna. There are some diamond pipes. From the diamond pipes, the diamond goes and deposited in the conglomerate. As I told you, it is a heavy mineral. So with conglomerate it will concentrate. Now this pair, the craton has diamond pipes. Now those diamond pipes, they themselves yield diamond, but same time also it releases diamond, which is taken by the water river into the basin and deposited along with the conglomerate. Vindhyan as well as Kadapa. These two things you should remember. Okay. So this is, I think, all about Kadapa. I'll just cover one more basin, that is the Pranita Godavari basin. Very interesting, I'll tell you. We'll go to that and then I think these three will be sufficient for you. Now you come to Pranita Godavari. Now you see this map. Now Pranita Godavari, very interesting, because we always read Pranita Godavari for our Gondwana coal fields and also for some hydrocarbon oil field. Now, but you see the map of Pranita Godavari, I will draw it, yeah, so that you can remember. I will draw it in the blackboard first. Then I will show you the detailed map. This one is Pranita Godavari. This is Pranita Godavari. You see, that day I was telling, like this you see. One is your Mahanadi gravel, Mahanadi river, Mahanadi. Then this Godavari. Godavari is also other name is Pranita. The top part it is called Pranita, Godavari. It's combined same river. So the river is like this. So now this where the river flows now, so there are some recent deposits, maybe tertiary deposits where there are some tertiary deposits where you have hydrocarbon. Hydrocarbon gas, not oil, hydrocarbon. That is the youngest formation in Godavari Valley, Godavari River. But Godavari River is famous for something else. Now, below this, you have this Gondwana. So that means Gondwana is the major deposit along this Godavari. This is Gondwana. Yes, Gondwana. Gondwana. Godavari Pranita Valley is famous for the Gondwana. Now, how this Gondwana deposits formed, I have told you last time. This Gondwana deposits formed by some river valleys formed. That means same mechanism. There are some rifting happened. Then so then gradually this block went this side, this block went this side. So a big valley formed. So initially the river was flowing. So that river valley deposit is Gondwana during Permian time. Now when the Permian beds were deposited here, initially everything was Precambrian. So what was the Precambrian rock present here, which had been extended or lifted to form this Gondwana valley? So that is the initial one. यहाँ क्या था? Where the extension took place and produced this Pranita Godavari valley, so that Gondwana could be deposited. So here was this platform. Which platform? Pranita Godavari platform. Proterozoic rocks. So it was like this. Here, platform rock was there, platform. Now it was lifted. This was lifted and gave way to the Gondwana deposits. So when the lifting took place, this platform rocks, it came this side. Here is your platform. This is your Gondwana. Again here is your platform. Here is your platform. Like this. So both sides on the two flanks of Gondwana valley, you have platform deposits, proterozoic platform deposits. And center you have this valley. The central part you have this valley, Gondwana valley. Now you see this map. Just focus to this map. Now this white part is your Gondwana valleys. This part, this shaded part, these two are your platform rocks. Those platform rocks will read. So when you talk about Godavari Pranita Valley, it has so many things. You have platform, you have central Gondwana, and also tertiary over the tertiary overlying. Recent sediments are overlying. And if you see further on either side, you have granulites, Archean granulites. Both sides, this side Archean granulites, this side Archean granulites, which is called Karimnagar granulites and Gopalipatnam granulites. So you have just come back to this place. So something like this I will draw again. This is Godavari. Here is your Gondwana. Then you have platform. Here is your platform. Then you have granulites. Archaea, 2.6 billion year. Platform is 1.8 billion year. Gondwana is 0.3 billion year. Like this, Again, if you come this side, again platform, again granulite. So this occurs as a pair. You see, platform, granulite. So this exemplifies, a rift valley which is existing from very old time, maybe Proterozoic time. Proterozoic time it is existing. The rift valley. Now let us see, we are interested now with the platforms, Proterozoic rocks. What are those Proterozoic rocks? Now these Proterozoic rocks, I will just write down. They are, this is your Gondwana, this is Gondwana. This side Proterozoic platform is called Albaca belt, A-L-B-A-K-A, Albaca belt. So Albaca belt, if some short note comes, you will be able to write, these are the platform rocks. Then this side is your Pakhal, P-A-N-E, right? K-H, Pakhal belt. So they were once totally same, continuous, but because of the rifting and formation of Gondwana valley, they have been separated. So Pakhal and Albaca belt. So I will give you a stratigraphic succession of Pakhal and Albaca belt. Sometimes this Pakhal is also known as Malampali belt. Pakhal belt is also known as Malampali. Malampali belt. This one. So, if I give a stratigraphic succession of Pakhal and Albaca belt, it is something like this. Malampali, group, then Mulung group, then Pengana group, then Sulewai group. Over that you have Gondwana. Over that Gondwana is deposited. Now base is, here they are writing 1330 million year, and top part is, people say 800 to 870 million year. So these two things you remember. You have Albaca belt, you have Pakhal belt. The central axis is occupied by, I will show you the map and discuss something else. I will come back to the map.
Krishna Godavari. Yeah.
Now you see, I will just enlarge it. Now if you can see little closer, you have Gondwana sediments at the center. Then eastern belt, western belt. Western belt is known as Pakhal and eastern belt is known as Albaca belt. The dotted, these are the platform deposits. You see how they are standing as a pair. Then if you go to further west, then you will get the migmatites, granites, granulites. Similarly, if you go to the other side, granites and migmatites you will get. So this is how the Pranita Godavari valley is distributed. So if suppose somebody asks you, what is this Pranita Godavari, you don't immediately jump into it is famous for this oil and gas or coal deposits only. You say that it is an ideal rift valley. Ideal rift valley in the sense you can see the older rocks on the shoulder in a symmetrical fashion. So Gondwana is deposited in the Rift Valley. So what it is broken? The Gondwana Rift Valley broke the Proterozoic platform rocks. What is the platform rocks? Your pokhals. Pokhals and albaca. They are one and same, but now they have been split up into two parts. And followed by the albaca belt or the pokhal belt is followed by the granulites and granites of the craton. Who is craton? To the east, you have Bastar craton. The west, you have Dharwar craton. I will draw it again. Because sometimes, you are asked to draw some maps or figures, in the interview board. Like here is Gondwana. And this side you have albaca. This side is pokhal. This side is your Bastar craton. Bastar craton, in which you have this, and this side is your Dharwar craton. Dharwar craton. Here Karimnagar granulite. Karimnagar granulite. Karimnagar granulite. This side is your Bastar granulites. So the granulites are Archean, cratonic part. Granulites are cratonic part. Then you have Proterozoic platforms. This is platform, and these are Gondwana. So these Gondwana deposits, in other cases, in Mahanadi or Narmada zone, they are on the craton itself or mobile belt, but deposited over a platform deposit. I think this is the early example. I will write down this sentence so that you will not forget. The Gondwana deposits in most cases are deposited for over, say, Mahanadi Valley, the mobile belts, belt के ऊपर formation हुआ, और the craton, but Godavari Rift Valley, the Godavari, Gondwana, formed over platform sequence. Or Purana sequence. Platform rocks in India we call it is Purana Group. Over that it is decorated. This you should remember. Now, what I will show you, I think this is all about the Pramita Godavari platform. I will show you some of the platform deposits, some of the Purana Group of Rocks, their occurrences. Let us see them. Where are they occurring? Now, let us come to Chhattisgarh. You see the Bastar pattern here. Bastar pattern you see. There are so many patches of platform rocks. Krishna Godavari you just leave in the south, Krishna Godavari or Godavari Pranita. But you come to the northern part, the Chhattisgarh. Two is Chhattisgarh. 3 is your Khariyar. 6 is your Indravati. There are small platform sequence of rocks and the Purana rocks which are occurring over Bastar craton. So I will just give their names. This map anyway I am going to send it to you by mail. So now names are written below. Khariyar Basin, then Ampani Basin, then Indravati Basin. So some of those names you should remember. But I will not go details about this platform deposits because they are very small in occurrences. But one very important point I will just tell you, that is Chhattisgarh basin is very close to the Eastern Ghat mobile belt. I will just show you whether I have that note or not. Yeah. Because I will take some water. See, the second one is Chhattisgarh. You can see what type of outlook pattern it has. Second one is Chhattisgarh. So Eastern Ghat is this side is Eastern Ghats, and this is Kraton. Over the Kraton, all these platform rocks are deposited. So that means you have a very large ocean here. Eastern Ghat mobile belt is a large ocean, and these are the appearing sea deposits. So Eastern Ghat and these deposits, they are in the same tectonic setting. Eastern Ghat was the major sea, open sea, just like Atlantic Ocean, and these are the appearing seas. Chhattisgarh, this is Khariyar, fourth is Ampani, this is sixth is Indravati. Like this different names are. 4 is Abu Zamar. So these are the over coastal pattern, this platform deposits are there. So they are almost horizontally bedded rocks. But as you come towards Eastern Ghats, you will find some difference. As you come towards Eastern Ghats, you will find some difference. Now, what is what I want to tell you? There are many companies. There are many companies which are now. Just I will draw it. This is the Eastern Ghat mobile belt. Huh? This is the Eastern Ghats mobile belt. Mobile belt. So as I told you, this was a larger sea. Here is your Chhattisgarh. Then if you come here near Khariyar, there is a place called Khariyar. Those who belong to this area, they know Khariyar. Then there is a small Ampani. There will be Indravati. Then Abu Zamar. Like this, there are several. Sukma. There is another called Sukma. Savari. Very small occurrences, But now, imagine this was a large sea, and these are the small landlocked seas, or they were partially connected with the Eastern Ghats Sea. Now, because of the plate tectonic, with subduction and continental collision, this mountain belt form, this erosion form, so they remain as platform rocks, undeformed, unmetamorphosed, whereas Eastern Ghat is metamorphosed, strongly deformed. As you know, Eastern Ghat is a thoroughly granulite belt. There is no low-grade rocks. But here, same as rocks, but they are not metamorphosed. They are not deformed again. So, what I want to say, this was one and the same sea, the Proterozoic sea. Only this part, this here there is a mild difference. Now we have done some extensive work here, Eastern Ghats as well as Khariar Basin. As I told you how controversy starts. See this Khariar Basin, Chhattisgarh Basin, as you know, the one and the same, and people have dated 1800 million year is the basement, and top one is 970 million year. Some people. But what we have found, the top part, lower part is 1800, it is fine. But top part is something around 500 million years. In our way, so they apply some other techniques, we apply some other techniques. So like this, all these Purana rocks pose a great challenge in the sense, the lower part is more or less fixed, around 1800. But the top part, whether it is around 1000 million years or it is gone up to Cambrian, that point is not still settled. Some people take Adigarhan fossils, we do some structural setting, structural pattern to say no, the extension, the deposition has gone up to 500 million years. Like this controversy remained. Now what I was telling, this bed, there are so many platform rocks. So our experience with Vindhyan and Kadapa, they are all diamond bearing. So many companies, including Geological Survey of India, they are extensively working in this area to locate for diamond deposits. Pipes, kimberlite pipes, or the conglomerates bearing the diamond. But there are some occurrences, but we have not, still till today, we have not hit any target. See, like Chhattisgarh, we have seen, we have done some field work there. There are some diamond old mines, but when you go there, there is no diamond there. So, like this, the western part of Odisha, this near Khariar, there are some diamond pits. Long time back, people have taken it out. So, diamond is famous for this part of platform and the Craton Association. Very famous for diamond deposits. Diamond deposits. Now we should, in future, suppose you are employed somewhere like Rio Tinto or there are many Vedanta, they are also working, Geological Survey of India. So these areas are famous for that thing. Economic part I am telling. Platform and Craton Association is famous for diamond deposits. Remember. Kimberlite pipes will be there in the craton and the diamond bearing conglomerates will be there in the platform. So these two, if you can target or if you can find out, nothing like that. But these mobile belts will not help you. Mobile belt you will not find any diamond. If it was there, there is a metamorphism deformation, now you cannot search it. You cannot locate it. You cannot locate it. Okay. So these are the Boston Craton platform deposits. And two more only remain, that is your Badami and Kaladgi. The west coast platforms, you have, here is your Bhima, then Badami and Kaladgi, Badami. Very small occurrences of limestone, shale and sandstone and conglomerates. So they are Bhima basin. This is very famous for uranium deposits. Uranium in Bhima. Because we have been working. Some of who are working in the Bhima basin with me. So, we have gone to this area, you see, these are limestone, shale and sandstone rocks. Along the margin, we got lot of deformation in Bhima. The point is that basal part of Bhima basin is your uranium bearing. So, uranium came from where, you may ask? See, uranium came from the craton. So here is your Dharwar craton. Dharwar crater. Dharwar crater is there. So Dharwar crater has many granites, 2.5, 2.4 billion year granites are there. They have this uranium. This consists of uranium. So when these basins form, Bhima basin, Karali basins, so this uranium from those granite, they were released by this erosion and weathering and went and deposited in the conglomerate beds, basal unconfirmed. That is why this Bhima basin is famous for uranium. So this uranium in granite is in the U4 form. Then because of this groundwater action, this goes to U6. So U6 is transported in the water medium and come to the basin. Then it converts to U4. U4. This oxidation reduce by the redox character of uranium, it gets oxidized and gets reduced. So they are deposited in the Bhima basin. So now different organizations like AMD, Atomic Mineral Division, even GSI, they are investigating uranium in Bhima basin. So these platforms, as I told you, is famous for diamond. It is also famous for uranium. The basal conglomerate and the basal unconformity, they are uranium bearing. So if suppose somebody asks you from where the uranium came, you say that 2.5 billion year granites are there in the crater. So those craters releases uranium. So in this basin they are deposited. So how useful these platform rocks for us? A diamond and uranium. Uranium comes from where? Granite. Diamond comes from where? Kimberlite pipe. Kimberlite pipes are not very old. Kimberlite pipes are maximum age is 1.5 billion years. Kimberlite pipe. They are not very old. But uranium granites are very old, 2.5. So they have come from different sources. Diamond from kimberlite, this comes from the granite. That is why the platform rocks are so important for us. We should look for these deposits. Okay. So now I think this is all about the platform. I told you platform, mobile belt and the craton association in Indian subcontinent. More than this I will not go. We will go for some other topics from the next class. Then we will see. Yeah. Okay, we will stop it here.